Hello, boys and girls. Welcome to science. Today we are going to go over the difference between refraction and reflection. Now, don't get those two words confused. So, we're going to talk about that in a minute. First off, I want to start out with a review for light. And you've already went over that a little bit, but I think that reviewing a little bit will help you. So, light is a form of energy. It can travel in space. It travels in rays, and it will travel in a straight line until it hits an object. Think of a flashlight. Have you ever seen a flashlight go like this and up and down and go over objects, or does it shine like straight out in front? So, yes, light travels in a straight line, and they call those lines rays. So, they travel in rays. It could be man made or it could be natural, like the lights in this room are man made, they're artificial, or it could be natural light, which means like the sunlight out of my window. And we get our light from the sun. So everything revolves around the sun. Think of the photosynthesis. Think of like the life cycles. It all starts with the sun. That's where we get energy from our plants and for our animals too. So light's very important. So remember, when a light hits an object, it's going to do four things. It can transmit the light, which means light goes all the way through an object. It can reflect light, which means it'll hit it and then it will bounce off. Refract means when light passes from one thing to another or one medium to another, it'll slow down or change its speed and then it will bend. So that's refraction. Absorption, that's when an object takes in light, and Miss Long is going to go over that in a few days. So you need to know these. Um, this is a picture or diagram of all the ways that light can hit an object. We have reflecting, refracting, and absorbing. So this shows the light rays. You can see that reflection, it'll hit it at an angle and then bounce off. Refracting, it's going to hit it, it's going to bend, and then it's going to go out. So you could see right here that refraction, it's bending. It almost looks like a corner or like an angle. Absorbing means it's going to hit and it's going to stay there. And then you'll figure out later what other things go with absorption or absorbing, okay? So I'm going to let you pause this video and I want you to copy down this anchor chart. So, and it's kind of blurry, but you can pretty much see it. So light travels in a straight line and they have a ray there. You can pause the video and copy it down into your science notebook. It can reflect or bounce off surfaces and it has some examples. Sunlight will hit the green leaves on the plant and go, it'll bounce back off and we see green. You see a reflection in the mirror. And refracts means that light will bend when it passes through mediums. This is a straw in a cup. It looks bent because of that light hitting the water from the air and changing speed. This is a prism that we're going to go over. And these are two types of lenses, concave and convex. So you copy that down, pause the video, and I'm going to move on. So reflection is our first one. So think of reflection. We do a little dance in my room. So if we do reflection, we're bouncing up and down. Reflection is the bouncing of light. When light hits a surface and it bounces off. When you look in the mirror, you see your reflection every morning. When you do your hair and you get your hair did, you look in the mirror and you see your reflection. That mirror is smooth, so light hits it, bounces off, and that's why we see our face. And it will most likely give you a reflection when it's a smooth surface, like the mirror. Or if you look at this lake right here, you can see the reflection of the trees because the water is still and calm. So that's how you'll see your reflection. Now, if the water's wavy and rough, you're not going to see it because the light will hit it And because it's rough, it'll bounce off in different directions. So you'll only see a reflection on a smooth surface. And those funny house mirrors that you all go to where it makes you really tall or really short, really fat, or really skinny, those are reflection as well. So you're going to see yourself in that mirror because it's a smooth surface. Light's going to hit it, and it's going to bounce off. So here's a cool experiment that you can do. If you take a flashlight and hit it on a mirror, you can bounce the light off and hit different items like on the wall, or you can hit this guy's shirt right here. Um, Also, like if you take a DVD and you turn it upside down on the silver part, you can take it and like do this or do a reflection. And like even my ring right here, the light will hit it and bounce off, and you can kind of see it on the ceiling. You could do that to your brother or sister to aggravate them, or your parents, but don't tell them I said that. Take the DVD and kind of bounce it off and hit them in the eye, but use caution when you do that. Um, so why do we see color? So here's an example. So if you have like grass, all the white light coming in, like the colors of the rainbow, we say Roy G. Biv. So red, orange, yellow, green, blue, indigo, and violet will hit that green, but only will hit the green grass, but only the green will reflect because that is the color that we're seeing. So all the colors will be absorbed except for green. Green will be reflected. That's why it's green grass. So look at this banana. All the white light is hitting it except for yellow. Yellow is being reflected. So that's why bananas are yellow. That's why my shirt is red. All the white light is being absorbed except for red. Red is being reflected. So that's why my shirt is red. Here's another example of this little guy. He's missing his body. So all the colors are going to hit him. He has a black hat though. So when something is black, all the colors are absorbed. They're not letting any out. That's why it's black. And the shirt is red because red is being reflected. All the other colors are being absorbed. He has blue shorts because all the colors are hitting it except for blue. Blue is being reflected. Now his socks are white. So when something is white, it's reflecting all the colors, all the light. So white objects reflect all the white and they appear white. Now here's a question for you. So if it's hot outside and it's 100 degrees, would I wear a black shirt or a white shirt? Yes, I would wear a white shirt because white shirt is going to reflect all the colors, but a black shirt is going to absorb all the colors and it's going to be much hotter. So that has to deal with light. Wear white on hot sunny days, not black, because black absorbs all the heat and the light. So now let's talk about refraction. So refraction is when light passes from one medium to another. It's going to change speed and it's going to bend. So here's an example. If I have a glass of water and I put my leg in it, or not a glass of water, you can't do that. So let's think of a pool. If you put your leg in a pool and my leg looks broke, what's happening is the light is coming from the air and it's hitting the water and it's changing speed. So the light is bending, but my leg isn't really bending. It looks that way, but the thing that is bending is light. That's refraction when light bends. So the dance to that is we're going to bend like that. That's refraction. Okay. So if you have lenses, like this magnifying glass has a lens in it, there are two different types of lenses that you all need to know. And this uses refraction. It's going to bend the light. Convex lens is where the center of the lens is thicker than the edges. Then you also have concave lens. That's when one is the lens is one where the center of the lens is thinner than the edges. Now, one way to remember, if it goes like this and caves in, that's a concave lens, but a convex lens would be the opposite. It's going to go the other way, okay? So lenses use refraction, and they help us see better. So they make things appear smaller or bigger to help us see. And here are some examples. So if I put a straw in a cup, the straw is going to look bent, but it's not really bent. It's the light that's hitting the water, it's slowing down, and the light bends. That's why my straw looks bent. That's refraction. Lenses are also used like in microscopes, glasses, binoculars, telescopes, magnifying glasses, and cameras. So they are bending the light. Again, they make things look bigger or smaller, and they help us see. So lenses are refraction. Now, anybody ever wonder how come we have rainbows? Or look at this little girl right here. She's spraying a water hose, but why is there a rainbow? And also, sometimes you can even see it in here. Why do raindrops look like they have colors in them, like the rainbow? Roy G. Bibb. That's because of refraction. The light is coming from the air and hitting that water and slowing down, and it looks bent. So that's why you see a rainbow. And here's some other examples too. I also like to use, like, if you put your net in the pool, or if you're spear fishing by chance, or my kids like to bow and arrow fish. So they have to aim at a different angle in order to hit the fish. Because if you hit straight for it, that's not where the fish really is. That's refraction. So the fish are going to be in a different spot. So that's refraction. Now, also with the raindrop, it can be reflection, because if the rain comes down and it makes like a water puddle and it's still and it's calm, you're going to see your reflection as well. So that's why you see the colors of the rainbow. In a few days, maybe tomorrow, I'm not sure, you're going to learn about prisms, triangular prisms. If you shine a flashlight into a prism at a certain angle, it will reflect the colors of the rainbow because it's bending that light. And the white light separates it into different colors. Okay, so you have learned the difference between reflection and refraction. Think of refraction. If you've ever fractured your wrist, it's going to be like bent, kinda, not feeling very well. So think of fraction. Refraction means you're bending, okay? Like the bending of light. Reflection, you see yourself in the mirror, light hits it, bounces off. That's reflection. That's the difference between the two. Now, what you're going to do today is you have a coach, or not a coach lesson. It looks a little different from our old ones, but you're going to focus more on refraction, and you're going to answer 6 different questions, okay, about light. Now, if you need to go back and rewatch the slides, you can. If you're still having trouble understanding it, make sure you have copied down the anchor chart into your science notebook. And I will see you soon, guys. Bye. Have a great day.